on the laptop.
Oh, okay. Cool.
We are live. Hello, everyone. There are 8 people here. Let's see. Okay. Welcome to Falcon Space. Oh, we got ourselves going twice. There we go. Okay. Don't be shy. Join in the chat. Everyone come say hi.
Hello.
Hey. We got Ned and Marcus here, and we are running the Alzofon experiment today. Quick overview of what that is. So that is dynamic nuclear polarization, or basically this paper by Frederick Alzofon. Anti-gravity with present technology, written in 1981. And in it, he describes a way of orienting subatomic particles as a method of anti-gravity. Yeah, you'd want to shut that off so we don't use up all the extra bandwidth here. In this variation of the experiment, we're going to be introducing a new component called quadrupole moments. Basically, every time the microwaves turn on, there is going to be a pulse of magnetic field that is going to expand the region of potential couplings. So we'll basically be slewing different gyromagnetic ratios in a relatively small range. We'll be slewing several potential gyromagnetic ratios and hitting all of them. And then on the down pulse, we'll be able to use all of those gyromagnetic moments to orient the subatomic spins. My t-shirt, you matter. Unless you multiply yourself by the speed of light and your energy. With us, we got Marcus. Max, you want to introduce yourself?
How you doing? I'm Marcus.
That's not an introduction.
I work here. What am I supposed to say?
You just... Okay, whatever.
Go with it.
And Nedd Popovich is here.
Hello, I'm Nedd Popovich. I'm a scientist. I'm here to help out Mark discover the new and validate the anti-gravity effect from an Alzofon experiment.
Alrighty. And you're also doing something with spinning magnets.
Yes, we're trying to also validate if we can create kind of like a stairway or a levitating effect to replace the common cable elevators into a space elevator.
Yeah, that's another cool project. Maybe you could bring that out later and show everyone how you get the magnets to float. Okay, this is probably going to be a bit boring, but we're going to be actually setting up the experiment. It's not fully set up, and it's going to be a pretty long live stream. So if you guys have any questions, type them out in the chat, and we'd get to them as soon as we can. Okay, so you want to carry the camera around, actually? Carry it around. So we'll be able to show off different parts of the setup. So over here we have signal starts over here with a microwave signal generator, and it goes to an amplifier, which then goes to a whole bunch of microwave waveguides over here, and then they get fed into the chamber. So basically the microwaves are pulsing in this direction. There's a B field going in this direction. So that allows microwaves and the magnetic field coupled to electrons. And if you pulse them just right, you're able to do what's called dynamic nuclear polarization, where you're orienting the spins of subatomic particles, using the electrons as a pathway to the subatomics, to like the protons and the neutrons. And that's where we believe the magic of anti-gravity actually happens. Somebody has a question there. Can you read it?
Question is, have you lost funding yet? So I can
Oh, that's Bernie. Bernie can go fuck himself. Yes, I'm sure he's been doing that a lot. He thinks we're funded by Israel and who else? Yeah, just say it all, Bernie. Oh yeah, he thinks we're funded by Israel and the Mossad. I haven't seen my paycheck from Israel yet.
The Mossad loves hiring people who are openly Jewish to say that they're Jewish, because that wouldn't be obvious.
Yeah. Don't don't support the trolls. Okay, so how do we start? So we got a sample in there. This sample is actually polarized aluminum coated with iron in our vapor deposition machine. We've been working on that for quite some time now. Actually, getting the vapor deposition machine in this room up and running has been quite a challenge. There's been a couple leaks, and finally got that going. So now we have a fresh sample with iron coated. So that's ferrous material on top of paramagnetic material. And Bernie, we still love you. I hope you feel better and get the help you need. No, but Bernie is like the master of chill. He's really good at that. Okay, so we're gonna start by turning on the traveling wave tube amplifier, and I'm not gonna turn on the signal generator yet because when you turn on this, when you get the thing heated up properly, it actually puts out a broadband radiation. In the microwave range of its range, so it makes noise, and then on the reflected signal, we're able to see where the critical coupling, where the right frequency would be to couple to the chamber. So as that warms up, let's go through other parts of the system. This over here is the sample holder. So there's a mechanism in there that allows us to move the sample around. We have X, Y, and Z controls. And yeah, this came off of a transmission electron microscope. Actually, this was pretty cool. We also added in some other cool components. This is a helium recycling system. So we pump helium into the system to keep the samples cool. This is probably going to be for a later generation when we're starting to do triplet state excitation. That's using a laser and crystals. So we're going to be exciting crystals of pentacene naphthalene grown here at the lab. And that would create a temporary ferromagnetic state. So it'll be temporarily ferromagnetic. Microwaves can couple it to better and then transfer that spin orientation even better to the core. This is a new variation of dynamic nuclear polarization that was discovered in the last decade or so. Relatively new science. And we are the only lab I know of that is attempting this and measuring the weight of the sample as it undergoes it. In order to get into that triplet state, you need a laser. So we have a massive laser over here. I'm going to bring this around. We've got to do a little yoga to get through here. This is our, we call it the Jewish space laser. I'm sure Bernie would love that. That's because we got a little... a switch to turn it on actually says Jewish space laser, and it has a warning on the back. So you need to be careful with the Jewish space laser. Never fire the Jewish space laser at unsuspecting space aliens in order to avoid potential intergalactic conflict. And inquire with the Space Force if you or any of your loved ones were abducted and or probed by aliens, a direct result of a JSL-related celestial altercation. Yeah, this was actually made as a joke. Because of that Marjorie Taylor Smith Green, right? She claimed that the Jews were responsible for the fires in California, and they were using space lasers. So somebody made a switch, and I actually connected it into this dye laser system. And this feeds a fiber that goes into the chamber. We're not going to be doing that today. The sample we have in there is just coated in ferromagnetic material. It's not actually, you can't turn the ferromagnetism on and off. And Simon says hi. Hey, Simon. Okay. Let's see if... oh, yep. So the traveling wave tube is in ready mode. We're going to turn it on, and look at that. Right when we turned it on over here, you see that little dip there? That is the coupling of the chamber. So that's basically reflected power, and then the reflected power drops down significantly at that point. It tells us that that point is the that is where the chamber is not reflecting power back. So the power is being absorbed by the chamber. It's basically critical coupling is something that only happens in microwave systems where you can pump, or microwaves or higher frequencies. You can also have this with lasers as well. You can pump energy in without it reflecting back, and then it builds up like a resonance. This is known as a Q factor. So the higher the Q factor, the more times the energy can bounce back and forth before it dissipates. So that would be really reliant on how reflective the walls of the chamber are. So this chamber is silver. Silver is one of the best reflective materials. So it works really well. And we also did some other magic to it, which is our secret. And in order to get that Q factor up even higher. Yeah, that nice dip over there shows us that we are golden. We're going to be, if I can just find where it is, let's go to marker. Move the marker up. No, I can't move the marker over because this is being controlled by the computer. But I believe that is around 2.975 or so. So we're going to go to frequency 2.975 gigahertz. And then we'll do the amplitude, -30 dBm. And then RF on. Okay, we're way off. It's actually higher than that. Frequency. You can see the peak over there on the no, yeah. On the left, yeah, that peak. Okay, I'm gonna do increment set. We'll set it to 500 kilohertz. Just to make it move a little faster. It's actually closer to 3 gigahertz. I was wrong. 2 right here. Yeah. So you'll be seeing that peak move over to the right. I'm trying to intersect that spot. 351 megahertz. So as that interacts with that dip, you'll see the peak will actually drop in magnitude significantly. And when we get it to drop to its lowest possible level, there, I think set it on 100 kilohertz. Now, can you give me one of the small rolling chairs?
Yes.
They're out this way.
Where did I see it?
Alrighty. Okay. Okay, so now there's one more thing we can do to tune this. That is there's an iris control over here. It's not responding much. Oh, there goes the responder. And Bernie, this is what real science looks like. Bernie has the best pot in the world.
Is it cast iron?
No, the type of pot that you smoke.
That was a dad joke.
We were trying to fix cast iron before, that's right. Oh, look at that. I got it almost all the way down. I'm playing with two things. I'm playing. Ooh! Ooh!
You had it.
Ooh! Yeah, buddy. Look at that. And anything I do, like, even if I change environmental factors, such as like moving my hand out of the way. Ah, nice. It's getting good. We should be recording the debate. Let's turn the recording thing off. Where's the here? On this screen, you can activate anti-gravity mode. What timestamp are we at?
We are at 15:26.
Why isn't that reading forward power? You get 3 gigahertz. That's not correctly. Just trying to trace all the RF connections. Do we have any serious questions? Worked for Doc Brown. And Tim Ventura just joined. Just read off comments that you see.
Simon says he's almost at his goal for American citizenship application.
Simon. He's the right kind of person. So we're gonna start introducing pulses into the microwaves. Let's see, we'll figure out what frequency to run everything at. Let's set it up over here. Just do this, okay, so square wave, and let's say 500 hertz for today. So basically, we have to pick the frequency that the whole process is going to happen at. So we have to incorporate both pulses of magnetic fields and pulses of microwave to happen simultaneously. We're going to have to tune the pulse magnetic field using capacitors to get the inductance just right so that the signal shows up correctly. So there's a couple things we're going to have to tune right now. And you might actually hear a hum from all this stuff happening. Start out by chilling the whole system down. We have a water chiller to cool down the magnet and associated equipment. So, there's no power in there. Plugged. Let them know. noise right now. The VOP output. It's not doing much. Can you get me those DNCT anchors? So good on there? Got any more comments?
Nothing yet.
Okay, so the signal's going into that, but it's not coming out. Are we actually even reading the output signal? VOP output. Oh, yeah. It's disconnected. Did anything change on the oscilloscope? Talk to me.
Not much.
What? Nothing changed?
Weird.
Oh, it changed. There it is.
Nice. It's a big picture.
Okay, that looks horrible. That looks like shit. QD. You try removing those capacitors, see what happens. The ones with the outlet, so just touch one side at a time. Okay. Hard. It's different. Very different. Might need I need monthly passwords. Let's come back in. continues than that. Preferably, you just want one big spike. Yes.
You're going to hit the right voltage.
This is the input voltage. Move one side. No, it's just.
We're getting some questions coming in right now.
Yeah, any question?
One guy wants to know what's in the cabin cage thingy.
Cabin cage thing.
He might be talking about the clean room on the right.
Oh yeah, go keep the tour later. So the problem here, I'll give you an overview of what's happening. So this is without the capacitors. Put the capacitors in. This is with the capacitor. So what that tells us is we need more capacitors. Basically, we only want one spike. We don't want any of this other noise happening in our signal. But you can go give them a tour of the clean room.
All right. Door into the clean room. Sticky pad. Clean any schmutz off your boots. Lights turn on automatically. In here, we've got our vapor deposition chamber. It's basically a vacuum. Inside here, it's kind of hard to see. This is all mirrored out because yesterday we did some aluminum. But inside this, you've got some plates. I'm not going to take it off right now because it is running. But you got some plates inside here that you could put whatever on that plate. And then you've got a couple of electrics in there. Runs through, gets it super hot, vaporizes it, and deposits it onto whatever is in that plate. So yesterday we did that with some iron. We deposited it onto aluminum. And that's what we do in our clean room.
Marcus, give them all update.
Give them a quick tour of the clean room. Next question is, when you have a moment, could you please send me the dimensions you used for your first gyro prototype? I'm planning a similar sized build, and I'm curious what you used. That's from Simon.
First prototype. I don't know. I built so many gyroscope machines. I'm not even sure which one is the first. But we are continuing that. We do have a new version of that's that we're working on. Simon, if you want to come to New Jersey, we could work on some cool gyroscope shit. So we actually have a project over here. We're trying to build a 3 gyroscope system. And the reason for 3 is because 3 is inherently unstable, and that might be what you need. So this is this is what's called a triad. It's a type of flow toy. And if you play with the inertia of a triad, you'd see that it kind of like wiggle in all directions. So I was thinking if we built gyroscopes that can pulse in a triad formation, it would be it wouldn't have any direction to translate that motion to. So like when you have two gyroscopes like kind of pulsing like that, they want to go up and down. The only reason why they're moving across the table is because they're forced down by gravity. They wouldn't work in outer space. I think a 3-way one would work in outer space, and we're going to use an ear piston to like pulse it all with a like a mechanical mechanism. We have a whole plan for that. We can use some help building that as well. And Aiden, please encourage him to peacefully turn himself over to the authorities and seek help she needs. Yes, you can. Bernie, get on it. I agree with you on that. Okay, do we have the capacitors? We throw more capacitors.
Okay, what size?
Just throw them at it. Where'd you put the box of capacitors?
I moved it so you'd have room for the laptop.
Okay. You put them over there. We can't use electrolytics. We have to use
I just looked up there. Truck.
You find the biggest one now. Cards. Yeah. Maybe like chain it together and use the alligator stuff. Just try to like use a chain of them, stick them together. Quick update. So we're going to try to add a bunch of these polypropylene film capacitors in line just to get the pulse to look just right. And we're going to use alligator clips. Any more interesting questions? What else?
Simon says I'm going to use slip rings and one-way bearings to flip the orientation of the gyro during the return stroke.
That sounds really cool. That's not, I don't want to get on a call with him. That sounds like a really cool idea. Slip rings to flip the orientation of the gyro during the return stroke. Wow. Huh? They need to be in parallel. Not for the let's see. What else can be turned on simultaneously? Let's see what happens if we drop the beam cycle. Let's raise the frequency to lower it. I don't think we really care. It just wants. That's 5 breath. Let's go 3 breath. I only have another 5 microfarads left, so might be at the limit of what this can do. And that is attempting to make a supercapacitor there.
It was a regular capacitor, and then it got bit by a spider.
Yep. That's how it usually happens, right? Centering this out. Clean it up. Okay, who else just joined? Slip wings and one-way bearings. Sounds pretty cool. Hi, chat. Yeah. Oh my God. Yikes. Yeah, Aiden sent me a few messages. I haven't even read them. So Gene stopped by. What's up, Gene? So Gene has this really cool book that I was telling you about, Ned.
Yeah.
Engineering Infinity.
Oh, cool.
Yeah, and it's basically a translation of Russian anti-gravity research. Gene Sticko. He's a very classy guy. He wears cool coats. Yeah, it's the book by Gene Sticko. I actually have one of these were signed by them, and there's a Polaroid picture proving it.
I'm just gonna connect it up there, or
Whoa! Look at that.
look all right.
Ned, you are the man. Look what Ned just smashed together for us. Live on film. Look at that. Look at that. Those nice little twirls. That's going to hold pretty well. Good job.
So,
Yeah, you're going to need another pair of
I know.
alligator clips too.
I figured that.
Ned, you are the man. I was like kissing. Everyone was telling me, don't hire Ned. I'm like, no, we need Ned. They're in the voltmeter wire spots. Fun more of them. They didn't. There's no polarity to to those type of capacitors. To polypropylene, there's no
Polarity.
there's no polarity to a polypropylene. How do you attach that?
To this,
Yeah.
we have a.
There's screws over there that you can attach it to.
All right, got it right here. Should be able to see on screen what he's doing and if there's any change on the graph.
There should be a change on the graph. It should calm down all the mess beyond. You might have to raise the voltage a little bit. Might want to cover that as well. Okay, you could stick it in over here. Huh? I was saying put the entire capacitor in that box.
Are you watching the line?
Yeah. 3, 2, 1. Eh.
Whoa!
I got a.
Something jumped.
Yeah, you got a spark.
I got a spark.
I don't know. Is it any better? What do y'all think?
Well, until you played with it, it did flatten a little bit.
Let's take it off for a second.
See that? What the voltage?
Yeah, see the difference there?
The voltage limit is.
It flattens a lot once you plug it in.
Can you like connect it and disconnect it?
I love the sparks.
He's getting sparks there when he connects it. Alrighty. I think connected is better. Yeah, I think more capacitance is better. It's not going to be perfect, but
Unless you want more capacitor.
no. So what I think we need to do is have a separate signal generator channel for the microwaves and one for the magnetic field, because the input and the output of that. Wait, another option is to change the waveform. Maybe we could try a different waveform. See what a ramp would do. Oh, it's weird. We go to map. Pulse. Well, pulse is pretty much just a square wave. I think a square wave is the best. Off. Okay, so we're gonna have to do another signal here. Set this to 500. Is there a way to like couple channel 1 and 2? Let me see if they are coupled already. So first 4. Quality. Stop. Source and folder. Bad connection. Yeah, that happens sometimes. The bane of my existence, bad connections. Can you get another?
On physical levels, on romantic level.
Look at that. That's this is the kind of shit you actually deal with, yeah. Everyone's thinking about dark energy and like they think you're on whiteboard scribbling shit. You're dealing with broken BNC connectors. All right, let's try that again now. Something happened. I did a thing. Oh, I know what's going on. Okay, so there we go. Stay running. Oh, that one's 600. This is 500. That's the problem. Yeah. Okay, so they are coupled to each other. That's good. They're both running at the same 500 hertz. Wait, let's go back to duty cycle. Okay. So the P, I believe, is the microwave pulse output. So as soon as you start raising the RF, demodulation on, pulse control on. This is there. Okay, so we should start seeing something. Oh, that is not connected. Oh, that's not working. There we go. See how the pink just dropped? So what that tells you, the pink is actually the RF pulse. So we're going to keep the RF at around 25% duty cycle, and the magnetic field pulse signal in is at around 6%, but the output is around 25%. So we want these two to match. And if those two match, that gives us our RF pulse. Yeah, we're getting close to getting there. I'm just going to shut off the microwave pulse for a moment and recouple the chamber. That's done again by playing with frequency and thing I'm confused about is why this isn't getting a signal. Must be a bad wire here. Not on that. Do you have any more questions? Just keep an eye on the chat. Got it. Conversation's going. I don't know. Not working.
Simon says for his first prototype, he's probably going to go with only 2 gyros for use on a little boat. 3 or more would be ideal for space use.
It needs to be an odd number, Simon. If you do an even number, even on a boat, it'll bob up and down in the water because it translates the linear motion that you're trying to make into vertical motion. In order to translate angular into straight line, I believe you need 3 or 5.
Simon also says, meanwhile, you're actually swearing at poorly made electronics. It's like that in most industries now, too, especially with vibe-coded stuff.
Yeah. Yeah. Totally agree. Okay. Let's see if we can get that number down a little bit more. Still on frequency. Bernie's been warning us about 8 and 2, right?
Say again?
Bernie's been warning us about 8 and 2.
Yeah, something about burning down his ex-girlfriend's house yesterday, stole her son's guns, and is on the run. Figured I should let you know for your safety.
Yikes.
I can't tell if this guy's trolling or if he's legit.
No, I know this guy. He used to work here. He's yeah. I don't think he's trolling.
So you think this guy's actually armed, dangerous, and on the run?
Well, it was very far away. It was in New Mexico. Alrighty, I think we are ready to start moving towards the next stage, which is so we got that going. Let's get the magnetic field going. So this turn the magnetic field on.
Mark, I'm very serious about Aiden. He expressed to me and his ex-girlfriend that he's seeking death by cop. He's armed and dangerous. He hasn't shown up in his house, so he's on the run.
On the run. Nice. Thanks. Wish Aiden the best. He needs to go to an ashram or something like that. Some like spiritual awakening. Take care of him.
Or a padded room.
That might be where he ends up. That is the other option. So we're gonna generate a sweep. We'll do an increase version. Start at 4. 1 to 7. Loop rate of 100. There we go. Okay, so the magnetic field is being introduced right now. Clear out the screen. Alrighty, so we have a magnetic field of around 828 Gauss. The number is slowly rising. I just told the computer to turn it on. So modulation is turned on right now. I'm going to raise the RF power. Can you grab the spectrum analyzer over there? It's turned back. No, it's the one that's turned away from you on the right. Yes, that. Get a power cable for that. Plug it in. Oh, there's a power cable right here.
Right here. It's right here.
Yeah. First one. This one's the first. This is just to tell us how much radiation's in the room, whether we need to put on our silver hoodies. I'm going to raise the power to... Where's my power wheel measuring thing? -10. Let's go to -10. Amplitude, -10. Okay, I just raised the RF power significantly.
That changed a little bit.
Yeah, it changes everything. I've actually bought an RF hoodie thing. What?
If you save your mic, it's in.
Oh, good, yeah. Okay. Want to grab an RF hoodie?
Back here.
Take the lab coat off and put the lab coat on top of it. We are donning silver hoodies that protect us from microwave radiation. Allah Akbar. I went full burqa over here. No, but in reality, fuck Allah. He's just an alien. Alrighty, what just happened over there? There was some interesting noise in the signal, and then it just disappeared. Yo no sé. So the green signal is our the sample weight. So when I turned on the RF, there was something happened with the signal from the weight, and then it sort of stabilized after a little bit. Strange. Marcus, what do you got to say?
I'm just looking if there's any more comments. I do want to talk about that suicide by cop thing for 2 seconds, if you're all right with that.
Yeah.
Suicide, whether by cop or any other method, does not get rid of the pain. All it does is magnifies it and sends it to everybody else. Don't do that shit. Get the help you need.
Yeah, Aiden, if you're watching, we're praying for you, and I hope you hope you find peace and the support you need. So,
Yeah, I assume the clothing is to stop the demons.
it's the stop the microwave demons, yes. So, one of the things we've learned about flying saucers is if you get close to them, you can get microwave burns. So, anything that is going to replicate what a flying saucer does should give you microwave burns. And unless you're protected. So we made our own PPE protective equipment. This is like a silver coated nylon material, and a good friend of mine's mom sewed it into like a hoodie, and then we added these little flaps that are semi see-through and allow you to get really close to the microwaves without getting protected. Yes, bling bling. It looks really cool. Actually, many aliens that have come off of craft, there's been sightings of them walking around the craft with like a onesie of this type of material.
Yeah, like a silver type. Yeah, you're right.
Yeah. So it actually, it fits in with what we're doing over here. put
Those work, guys. I would put sunscreen on too. Not worth the risk.
There is no
UV radiation.
there's no UV radiation coming out of this thing. It's all microwaves. And what's happening at 2 p.m. tomorrow?
Oh, that's when Gene is going to be on Galactic Family.
Ooh, what's Galactic Family? Yeah. Gene's really cool. He came by here. We had dinner at the Peruvian place next door. Yes, we are back up and running. Okay. So the expected gyromagnetic ratio is right around now. Let's see if there's any wait.
Gene says podcast we can move on.
Ooh.
Not everyone in the audience knows what Gene's talking about.
Let Gene explain what MUFON is.
Mutual UFO.
Yeah, neutral UFO network. If you've seen any phenomena or experienced anything, you can contact them to help you. They're basically investigators. They've been doing this for many, many years.
I'm seeing something interesting is happening with the data. So every time the temperature probes spike, the so these are temperature probes, the red and the purple. They're not really that relevant for the experiment. They're just to monitor whether the traveling wave tube amplifier is overheating or something like that. But every time there's a spike over there, it correlates with the weight of the sample going crazy, which is kind of interesting. I wonder if this is a phantom or if this is just some sort of noise that entered the line somehow. But in the greater scheme of things, we're going from 8015 to 8009. So if there was a massive magnitude change in power, we would see something happen. I think we already, we're at 1137. So we already passed the expected gyromagnetic ratio. At 3 gigahertz, it's roughly 1070.
It could be temperature dependent, Simon says. Simon says,
Yes. Simon says it could be temperature dependent. That is a possibility, but it definitely is temperature dependent to a degree. We're going to do 4.5 to 6.
okay.
I'm going to change the range to. Ooh, something happened here with the weight. Podcast with MUFON. You guys have any experience with MUFON?
No.
No?
He was telling me what it was. I'd never heard of it prior to 10 minutes ago.
No. MUFON has been infiltrated.
No. Really?
MUFON's been infiltrated for a long time, yeah, by government forces and whatnot. MUFON just looks at lights in the sky. They're not interested in any real science. And I know that for a fact because I actually messaged them asking if they'd be interested in having a anti-gravity research lab on their panel. They put me in touch with some guy who was supposed to be their science director, and I emailed him. He never emailed me back. I emailed him a follow-up. The email bounced. Same email address. Turned out that right after he got my email, there was some conflict internal to MUFON, and he was quit. or they fired him. Yeah. So
He was chairman of the FOAD committee.
FOAD.
F often died.
Yeah.
Simon, as long as we don't need to supercool it, we're good. Bob Laser, okay, good to know. Just make sure you don't test any bets.
That was the next thing that we were gonna do. Yeah, not sus at all, Simon, right? I'm sure it's a very good organization. They got their heart in the right place, right? Let's see what's going on over here. Generate number C.
Dean, how is your weight measurement electronics protected through the RF?
Lots of shielding.
Bob Laser, how are you stopping dirty frequencies from outside?
So we're using shielding and also isolating transformers on sensitive equipment. And if there's a known noisy piece of equipment, we put that on the isolating transformer as well. So we use the isolating transformer for both clean power out and protecting the grid from dirty power or dirty signals. Try lowering the power a little bit. Amplitude drop it to negative 15 dBm. Coming up on the expected general magnetic ratio, 1043. Signal is bouncing between 801 and 8008. 80145 and 8008. 008.
Pasadena, do you have any field probe you can put in place of the sample? Radio frequency field probe.
An RF field probe. Yes, we do. We could stick one in there and just read the read the RF. How is our weight measurement electronics protected from the RF? So the weight measuring electronics, which is essentially just a sensor probe, the sample goes through a tube. It's protected by a metal wall. The sample goes through a tiny hole, which is way smaller than even a quarter wavelength. And then on top of that, the sensor is protected with another brass cover, and then the entire chamber that it sits inside of, which is this one right over here, is surrounded by RF absorption foam. And we have run many null tests to see that it is not affected by any RF this setup can produce. There's some sort of sudden change in weight over there.
He says, that sounds quite nice.
So the green is our signal. That's the weight of the sample. Magnetic fields right now at 1142 Gauss. There was some sort of spike over here. That's around where the gyromagnetic ratio is expected to happen. Something did happen there.
Are we still pumping energy into the system?
Yeah, we're still pumping energy into the system. We might be oversaturating the sample. That's a possibility as well. Putting too much RF energy in can make the sample ring too hard, in which case it will never calm down. Negative 15. For the next sweep, I'm going to change it to negative 13. See what happens. The amount of energy that we're feeding is like in the milliwatts. It's not a very high energy experiment. Theoretically, the actual amount of energy necessary to achieve dynamic nuclear polarization is 0. You just need to overcome inefficiencies.
DNO needs super accurate RF down to many decimal places. How do you tackle that? Are you like scanning through the expected range
And
watching it change?
So the RF actually is kept constant because if you change the RF, then the coupling to the chamber would change. So you want to have the RF constant and the magnetic field sweeping, because it's a gyromagnetic ratio. It's a ratio between magnetic field and RF. So you can move the magnetic field or you can move the RF. Moving the RF is a lot more difficult. So we'll keep the RF constant and change the magnetic field slowly. And that's all controlled by a computer. So we're not turning a knob or anything. So there's a computer program on LabVIEW. It's right over here. These settings, start point, end point, loop rate, these things control the RF, the magnetic field sweep. So right now we're going to go to the amplitude, and we're going to drop it to, let's raise it actually to 17.5. We drop, no. We'll raise it to 12.5 dBm for a little bit more power.
Oh, the changed magnetic field makes a lot more sense.
Hey, who else is there? We got 22 people watching, only 9 likes.
Here, 10 likes.
Ah, you like it too? I'll let this run for a little bit. We could show off some other things that we're doing. What else are we doing?
The magnets on the wave.
Oh yeah, yeah. Let's go check out. Let's go check out Ned's magnet spinner. Ned, you want to show us the magnet spinner?
We can do that.
Ned's going to show us his magnet spinners. Floating magnet spinner.
So what we tried to do was actually simple to do, but the idea is to see if we can create a chain effect of magnetic bodies to go on top of each other, kind of like a stairway, if you'd like. What we've done here is we needed to machine, and we're using some very simple tools. We're using a Dremel tool, and we've tried to machine basically a magnet such as this, attach it to the Dremel piece, and then that's basically a magnet inside. And what we did is we put some epoxy around it so that it would not fly off, it would protect it. And then the idea is to spin this at about 10,000 RPM and get this to trap it and levitate on it. So I've been using here some really simple plastic container so that it does tend to fly off when you're trying to arrange it. And what I'm going to do is I'm going to put this 3/8 of an inch neodymium magnet right on the bottom of it. Let's see if I can show you the setup without moving too much. You can see the little ball right there. That's aluminum. That's all aluminum plates there. They were homemade by my friend Klaus. He actually molted some of the aluminum cans and gave me some of those samples. And I also have another aluminum plate. So the key is to get this to the right RPM. This way easier to see. It takes a few tries to get this to work, so bear with me. As I said, sometimes too fast. My fingers are too fast. I think I'm at the right speed. You can see it's starting to move. It's much better if you have a precise way to control this, but it starts to wobble. Almost caught it. Let's see.
This experiment works a lot better with cube magnets.
Yeah,
That's from Bill Schwan.
you're right.
I'm butchering the pronunciation. I'm sure. I apologize for that.
That's the next one. We've just made that. You're absolutely right about that.
Is this what you're trying to do?
This is just a separate experiment. We were trying to actually create a chain of these if possible. Problem is vibration and holding this steady, because there are some.
The very small solid point.
Yeah, that's good. Let's see if I can reset.
What's the ball made out of?
Neodymium magnet. And the aluminum is around to help with any eddy currents, because sounds about right. I know. Takes a while to get this just right. So I'm kind of adjusting the speed up and down to try to get it to the right thing. Obviously, these Dremel tools are not supposed to be made for precise control. It's not for this. That will be experiment number 2 and later on. What wants to pick it up, did you? And you got to be careful. This is why we do it like this. Safety first, guys. Always safety first.
He wants to know what's attached to the Dremel. Can we turn it off and describe it?
Yeah. What's attached to the Dremel? So just basically a shaft. I'll show you another one. So I literally used one of the grinding stones. I'll show you another one. So I literally used one of the grinding stones and used a magnet to attach it, like a magnet like this, or a square magnet that you mentioned as well. We glued it to the Dremel and used acrylic to surround it to get, and then of course Marcus helped me laid it down to as small of a size as possible. And that's basically what it looks like when it's put in enamel or acrylic, if you'd like. Actually, let's try the square one. I haven't tried it yet.
What if you had a plastic pipe and a narrower path?
Yeah, that's a cool idea.
And
That's a
then
great idea.
try the square one.
I would just
Simon wants us to try the square one.
Yes, sir. I hear you, Simon. Do as Simon says, right? Did Simon say that? Just kidding, by the way. Let's try the square one. I haven't tried the square one yet. I prefer the square one. And I go by the sound, actually.
Marcus, something pizza from Duddy's.
Sure.
Yeah. Maybe a little faster. There it is.
Are you down with the work?
Can you guys see it?
It's floating.
How about we get a drunken grammar guy?
What's that involved? Sounds like vodka sauce to drunken.
Yeah, that's good.
That's kind of the goal.
Their best feature.
And it does work better. You're absolutely right. I can get it.
So spinning a square magnet and a sphere magnet in the container. Swap the sphere magnet with an identical cube. That's way better. I suspended lead and lead/tin samples and observed what looked like nucleus polarization and changes in sample weight under a neodymium magnet.
Well, we should talk. We should definitely talk. That's fantastic.
That's John K 9964. I plan to upload them soon on my YouTube channel.
Yeah, man. And come on down to the lab. Let's work together,
At
man.
Inertia Drive 8915.
You can see that, right?
Tilt
Yeah,
it down
just
just a bit so you can see it better.
So the issue is that the moment you move it away from aluminum or something, you get shaking and wobbling. That's probably because you're using this as a rotary tool, right? But it catches it relatively. So the question is, how many of these can we put in chain? Do we have to increase the speed? Do we lose anything? That's a whole bunch of other questions we have when it comes to that. So that's what we have so far. All right. So John, you said John K? Yeah, John K 9964. Yeah, man.
Mm-hmm.
I'd love to get a hold of you. Share some knowledge and get some.
Give him your contact info.
Simon, being a wise guy, says now swap it with bismuth.
Oh yeah, we have bismuth. You want to put bismuth in there? There's
I'm
bismuth.
down to, yeah, man. The more we do experiments, I'm down. That's the whole point.
You can get blocks of bismuth. Here's bismuth.
Whoa, that's huge.
That's what
She
she said.
said. Big samples of bismuth. So what are we going to do? Try to, instead of using a magnet, use bismuth or
No. Instead of
aluminum?
I was infantry. What's your excuse?
Too many chemistry experiments.
He's talking about that kind of chemistry.
Look at this beautiful bismuth.
Can't see. Yeah, I got you.
Look how beautiful that is. It is so shiny, so beautiful. My kids love gems and everything else. They would love this. But this is for science, guys, not for. Let's try that. See a little bit so that people can see it. I'm just gonna drop the magnetic ball in the on top or in the middle somewhere. Let's see if I can get that RPM again. Sound about the same.
Mr. Cowboy asks, does it have to be aluminum?
No,
And the answer is we're trying it right now with bismuth.
and we're
And
doing
we're
just
gonna-
fine.
And we're floating, so no, it does not have to be aluminum.
Aluminum is just something I could get my hands on easily. Now I have bismuth, so yeah.
Electrokinetics Now says great demonstration.
See how far can I get them? Keep going higher. But you see, it wobbles. It does different modalities. It depends because the RPM is not being stable. This is not the most accurate way of controlling it. So what's interesting, guys, is that
Try the
what's
round
interesting, guys,
magnet with the bismuth.
there's only 2 or 3 papers published on this phenomenon. None of them were done in the USA. And I've tried now so many times to get NSF and DOE funding so we can experiment this and have some real data on this, so see how we can use it. So I'm hoping that maybe that happens one day.
Richard Muller says aluminum and bismuth may have the same magnetic properties. John
Probably.
K says, I didn't upload them before because the video quality is low and I thought they might not be interesting.
No, bismuth. Bismuth is diamagnetic.
You think your spherical magnet in epoxy will work with the bismuth? Because it didn't work so well with the aluminum.
Can I try playing with it?
Yeah. What do you want to do? I want to try to play with it.
Yeah.
Simon, it would be better to have a little microcontroller for adjusting the speed with a readout.
I agree. Yeah.
Oh, you don't need any bismuth. Let's see what happens if I put bismuth near it now.
Not much of this case.
Just for my own
But I
edification,
think
you
it's
should be
with
wearing
time.
glasses.
With
when you
time,
do
it's going to fall. I think.
Now, here's the big question.
Hold it up on top of this, please. I know what you're
that.
doing.
Mr. Cowboy East says that's volatile and aluminum.
Oh, as soon as I did that, it fell out.
Button says, I cannot explain what is going on here. Never seen this before.
Yeah. See, this actually somehow doing anything. It could be that the RPM went down a little bit too. You got it holding? Okay. Hold it up. Hold it up as much as you can. Keep it out of the plastic and just underneath. So I'm gonna try to do something, okay?
Can you just
Oh,
give
I-
me?
But I can feel it over here, man. Can you feel that?
As soon as
You
you
can
put the
feel
second one in,
I know. What
drops.
happened? Yeah, it drops. Let me go. You got it? So I think maybe by the sound of it, maybe try to dial it up a tiny bit.
Oh, let me play with it for a bit.
Okay, yeah, please do. Please do.
If you have a big enough magnet, you can levitate a frog. That's from Simon.
Well, technically, you could levitate an entire human if you put them in an MRI machine. Dialed appropriately.
From Bill, I have this experiment here in my lab. Red Collie is a good resource about this.
So the higher frequency brings it in closer.
Yeah. Brings it in closer, you're right. That'll be just right. Got it? Okay.
By the way, you're now at 21 likes. And 51 people online.
Yeah, they're all floating. I don't see why all this stuff is necessary. You just
You
need to
don't
hold
think we just need to pull? Okay,
You
so
need
it's
to-
probably
it. I don't think you need any of this. Just trying to keep it. I don't think you need the bismuth, and I don't think you need the aluminum.
Bill says, yeah, the bouncing is super hard to control.
yeah, no. The magnetic strength is much stronger. I have an idea.
I don't even know what part-time peasant is trying to say with that eyeball. Ben Martinek, make that 22. Great work over there. He's referring to the number of likes. Make that 22. Great work over there. I would like to try this in my own shop. Chazadim, are there eddy currents being created in the ball?
That's a good question, actually. I'm not sure. But any rotating magnet, and you put a coil around it, you'll get a current, right?
Johann Viscar, 5781. So this is basically superconductivity effects of magnetic lock on room temperature.
Actually, it's a really
Bill Schwan. So there we go. Got to be very smooth if you move it around. Emphasis on very. Simon, The aluminum creates eddy currents that should help repel it. Part-time peasant says that his eyeball means he's interested and he's watching.
Awesome.
Simon, it's not really locking since it's dynamic.
Well, it's true, actually. But Earnshaw theorems actually says that this is not possible. You can't do this with magnets. But he actually never spun them at 10,000 RPM. I just had two small magnets somewhere and they just disappeared.
Fazadim wants to know how the poles of the magnets are oriented when they're spinning.
Oh, that's important.
Yes. So the rotor, how about we just show it? Like this. So you can see the line that separates north and south poles. Sorry, it's kind of difficult to do on a camera.
He's talking about this line
That's
going this
right.
orientation.
That's right. So you have north and south horizontally. I always confuse those. And then obviously the magnet that's on the bottom will actually be up and down. So north and south vertically.
Oh, by the way, since a lot of people confuse that, here's a little trick that they should teach you in like 3rd grade when they teach you horizontal and vertical. When you look out at the ocean, the horizon is horizontal. They should tell you that. They don't.
You're right. That's exactly it. I have no idea where it disappeared.
Oh, can you do the this thing again? Someone said they couldn't see it.
Let me try. So this is basically a magnetic film, and it shows you. Now you can see. Let me see if I can block some of this light. You can see the color of like blue. You see me moving it around. So that blue shows you where the magnetic field is, or the circle around it. See if I twist it like this, you'll just see one pole. So that's actually kind of like the size of the magnetic field. If you go outside it, it won't affect it. And this just shows you the line that it's
Back
actually.
up an inch and I'll show them.
Yes. Let me see how I can put back. Oh,
There we
yeah,
go.
there we go. Maybe this is better.
All right. So there is a yellow. Do it this way. There is this yellow line and then the blue dot. That yellow line and then the 2 blue dots on each side. One on each side.
As I'm spinning it like this, you can almost imagine it as a 3D ball, right? With the north and south being divided in the middle of that with that white line. It's kind of how I can explain it the best. I hope it helps. I don't.
All right. So I lost where we're up to. How are the poles spinning was what we just answered. Magnetism is strongest at the corners. That's why this works and why the cube magnet is so much better. I assume he means better than the spherical.
I measured the Gauss of it actually, and it was right in the center of it. It had the strongest Gauss reading right in the center.
Then Hazadim says, "Oh, I think I understand." Simon clarifies, "It would be better to magnetize the cube diagonally then." Hazadim, I can see now.
So the moment I move, if I move too much, it starts to lose. You see, just a little shake of the Dremel. That's why we need to we want to mount this on something more sturdy and fold it up. And you're right, actually have a microcontroller so we can get the right speed and everything and more. This was just the first attempt. Validated this.
Bill Schwant says the bright white line is the block wall and always falls between the poles.
Yes.
This is what Ken Wheeler calls the plane of inertia.
Thank you.
Kazadim. So the magnetic vector at the ball is rotating then. Yeah, that helps.
Yeah.
Simon, yeah, sorry. Swipe keyboard doesn't think magnetizes a 45-degree angle.
If I can approach it at 45. Hold on. Twist this down.
Bill says, "Well done. I wish my Dremel bits were this nice."
So even at a 45-degree angle, you can pick it up. It really doesn't matter, man.
Kazadim. I'm really curious if the ball is spinning to and at what RPM relative to the Dremel.
So that's a great question, and that's what I've been trying to answer as well. I don't think it is the same speed. It's a lot less, and you can see I've attached what I've done is I've attached a little tiny magnet on the bottom to help us actually see how it spins. And you can see it like that. I don't think it's the same speed. Technically, it should be. But I wouldn't know how to measure that. Or at least I don't have a equipment to do so. Anybody wants to partner and do this together and you do have it, please let me know.
Electronic Kinetics Now,
Paint the ball in stripes.
Electrokinetics Now says, I saw a 2-inch
That's a good
aluminum
point.
round bar levitate a couple of inches between two spinning magnetic generators back in 95.
Ooh, that's awesome. Yeah, if anybody wants to email me, it's my name's right here. Actually, it's Nedd at futurecraftinnovations.com. Or just
Nedd at Futurecraft Innovation. Innovation says 2 N's.
Yes.
.com.
As soon as you introduce another magnet, the first one falls off.
But that's interesting. Look at the one on the bottom.
Wazadim asks, has the ball been
No, that's-
demagnetized at
No
all?
magnet, though.
I know. So it depends, I guess, also on the strength of the magnet. I'm sorry? What did...
Wazadim asks, has the ball been demagnetized at all?
No. No, what?
Mr. Cowboy East says, paint the ball in stripes. I assume he's talking about as a way to judge how fast it's spinning.
Yes. Thank you, bro. Love you. That's my brother.
Oh,
Here, yep. Let's do it from 2 angles.
see if
Oh,
you
yeah,
can
let's do that.
See if you can do it by dropping the sphere from above. Simon likes the striped magnet idea.
You're right. That's a great idea.
Simon wants to know how your last name is pronounced.
Popovich with a ch.
With a CH like chicken.
I think that one's too fast.
Oh, by the way, Mark, that's why I would appreciate it if you did wear eye protection. We don't need you going blind today. I mean, I hate to be a Jewish mother about it, but
No. Safety first. We said that at the beginning. Can we do something else? Let's turn that one off and use this one. Somebody taught me.
Ball JS. If one designed a solenoid code set up well enough, it seems reasonable to make those rotating fields with no moving parts. Just needs something like a brushless motor power supply. I'm picturing a Milwaukee M18 drill.
Oh, I tried that. They don't go as fast. Any drill doesn't go up to 10,000 RPM. Except these, the Dremels.
Dremels do, yeah.
Yeah. They're more for like power, strength to turn, everything else, not the...
This doesn't fit.
My T-brain would be cool to try Nedd's Dremel trick on the superconductor you have, Mark.
I would love that. That's exactly my... I just got to convince Mark if we can do a superconductor trial maybe tomorrow.
What do you want to do with the superconductor?
We want to... I want to actually stack... I want to cool it down and I want to stack it and see if we can create a ladder. What I do with it.
Exoplanet. If it was spinning anywhere near 10,000 RPM, believe me, you would know it when it fell in your hand.
That's what I
Don't forget, it's a magnet. It probably got stuck on that big thing that you just picked up. The thing you're touching, it's probably on there on the bottom.
I thought it went that way, like under the purple.
Oh.
Okay, so see, there's another ball.
Van in Mars wants to know, have you guys seen the film when a bunch of guys in a basement invent a time machine by accident?
No, what's it called?
Vanin, if you can give us the name of that movie, we'd appreciate that. Chazadim, very nice video today. Sorry I have to get going. Do this again sometime. Simon says, thank you. Bill Schwant says, I absolutely wrecked myself trying 2 Dremels together like that.
Okay, yeah. We have another one we can try. You want to try it in here?
Yeah, sure.
I'm not sure. If
Simon says he has a name that everyone mispronounces, so he tries.
I wasn't very successful with this one. Maybe the angle is not as good as that one.
Johan Viskar says, It's a good demonstration. It seems a self-stabilizing effect of interacting magnetic fields.
Don't use this
But
one.
what possible use could
Use
it
this
have?
I'm sorry, what?
He says it's a good demonstration. It seems a self-stabilizing effect of interacting magnetic fields, but he wants to know what practical purpose it serves.
Well, if you can create actually, let's say a chain, right? If you can actually stack one after another, after another, after another, you can create a maglev train to space. You can actually remove cables from elevator operations. You can create, if you look at the APAC, at the Alternative Propulsion Engineering Conference, look at the search for space train. I've done a whole presentation of what you can do on that as well. And it will give you a lot more ideas than I just mentioned.
You can move your sofa.
Possibly. I mean, I was thinking on a larger scale.
But I'm saying that you could scale it up and down. There's countless ways. Anytime you have to move something heavy,
Stage 1 of our space elevator, right there.
all right. XF1 Rex. Hello, boys. Long-term follower of Jeremy's here. Have you boys cracked it yet?
Yeah, bring it in. It's protected. It can't go anywhere. Wait, stop. Take it back.
Who is Jeremy?
Jeremy Reese. He's an alien scientist.
Oh, yeah. Hey, Jeremy.
Is Jeremy there?
No, Rex says he's a follower of Jeremy.
Okay.
Oh,
And he wants to know if we've cracked it yet. Vannon, are
Bring
they
it in,
two
bring it in.
magnets spinning super fast? Inside the Dremel itself is only one magnet.
Well, there's two of them. Well, now there's 3 magnets being introduced. Bring it in closer. Oh, wow.
Look at that. It's actually spinning from that far away. That's not.
My T-Brain says check the ball's RPMs with the tack and some reflective tape.
You don't need it. You don't need reflective tape. It's already reflecting. All you need is a Sharpie. Yeah, I want to try that.
Blind Pier says cool lab setting. Greetings from Finland. Van and Mars says the movie is called Primer.
Primer?
Primer is the movie he was talking about where they set up a time machine.
This is a really nice tip over here.
I'll have a look at it. Yeah, I think we should try
Doyle's
this.
interested.
We should try that more with these square. I think they're right. I think we should just use the balls.
Simon, Primer is amazing. 10 out of 10 film.
That's pretty good, huh?
Guys, I'm doing this, so I can't look it up right now, but one of the people in the audience, please let me know if it's on any of the streaming services. Simon says that Primer is mandatory viewing. Mr. Cowboy, have you tried smoke or some kind of gases to see behavior around the sphere magnet?
Bill Schwad. It looks like he's done it before. I couldn't get. Yeah. So this square one. It's actually just a square magnet, and the ball are pretty stable.
That's what Bill just said. Cuban sphere was much more stable than the way I do it with 2 cubes. I couldn't get it to work vertically with 2 cubes, but my bits aren't as nice as yours. I assume he means the Dremel bits.
Yes.
Which we spent a good hour or two this morning just machining them, getting them nice and square. You know, we took the epoxy onto the lathe, and
So
that was my humble contribution to this project.
if you want to see, prior to this, we tried different styles. This is a magnet inside, broke off. This actually bends, the shaft bends, so you need to have some good engineering and some good bends. The shaft bends, so you need to have some good engineering and some good hands to craft the right tool for the right job.
Right tool for the right job. Couldn't have said it better. Paul JS. Was
There it
everything
is.
done?
There it is, yeah.
Nice. Hold on. Video. Focus, 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 damn you. There it is. Nice. All right. Paul JS wants to know, was anything done with the rotating fields in proximity to a capacitively charged plate of some sort? Didn't catch this from the start, so not sure if that was one of the things done.
No, these are just rotating magnets.
Blind Peer, you've done any podcast episodes that I can listen to tomorrow at work?
There's a few documentaries. If you Google Falcon Space, you'll see, but it's not really. No, I should really get on a podcast.
Ben Martinek, instead of a cube, have you tried a rectangular?
Have you? Here, you want to hold it?
Yeah, not really. I have not tried it. I don't want to go too close because there's some other magnets or anything else in this room. I want it to fly off.
Let's hold it nice and straight.
Ben Martinek, I'm going to ask you, when you say rectangular, do you mean with the axis through the short end and it's whipping around like helicopter rotors? Or do you mean the axis through the long end so it's spinning on itself like a drill bit?
Because
Here, let's just be quiet for a second. I don't want to catch this from different angles. That is so cool. The rotating magnet. Oh, cool.
it's okay. That's my hand is not as steady as yours, Mark.
Well, you need to rest your hand on something else. So if you're just holding it out like this, then, then it's not just your hand; it's your arm and everything. If you do like this, then you're, it's just the instability within your hand.
Absolutely.
Simon agrees that smoke is a good idea. Rex says, just sending my regards to you chaps for the continued effort that you're making. Truly valiant. Someone needs to be doing this work. It's vital, important, especially outside of the energy cartels. I assume he's referring to big oil.
Yeah, energy cartels.
It's coming there. That's good. How are we at the experiment over there?
Oh, the experiment in the other room. It's had a couple runs. I ran back and made some adjustments. Any questions about the magnet experiment?
Simon wants to know, what if it was two magnets with like faces?
Put the damn drill in a vice grip. Yeah.
Forge actual vice.
Mm-hmm.
It vibrates a lot.
Do you have a strobe? Yeah, we got strobes.
I'm going to capture all these things and we'll run follow-up experiments. But for now, this was just a short demo for you guys.
But see at the data. Something's going on there. I'm seeing a little like.
Vannon is asking a philosophical question. He wants to know, if you found out your invention was as destructive as nukes, would you destroy it?
I don't know. Maybe.
Part-time peasant wants to know if we have a strobe.
We have a strobe, yes. What do we do with the strobe?
While we wait for him to type his answer, John Visker, you can build a space elevator on this principle as the magnetic field diminishes with the square root of distance to the rotating driver magnetic field. Oh, you can't. I'm sorry, I missed the T. You can't build a space elevator on this principle as the magnetic field diminishes with the square root of distance to the rotating driver magnetic field.
So then the question is, how do you
tell him? Don't miss.
So then, how do you increase it? In what way can you increase it? How do we do it now? In what other industry do we do that now? Could you wrap it with with some kind of a coil, put a battery on it, capacitated? What other ways could we do it?
Rex says you guys should do some experiments passing radio waves through statically charged waveguides over 1 kV. You might be surprised by some of the things that you observe.
Actually, that's what I want to also develop.
Will Schwant answers no. I don't know what he's saying no to. Richard Muller, have you ever made the sample in the Alzofon experiment spherical, just like the Dremel with the magnet? And Bill Schwan, magnetic trains sort of work like this. It's not exactly the same, but it's pretty close.
Yeah.
Ben Martinek. I mean the axis through the short end, like a helicopter blade. Okay, so that's what I expected. I just wanted to clarify. Maybe 2 to 3 times the diameter of the ball. Sorry if I missed this earlier, but the ball is also magnetized. So he wants you to have a long rectangular that's spinning this way with the ball where he hits.
Oh, I see. Yeah. That's a cool idea, actually.
We're going to change.
That's a
the
really
RF
cool idea.
power
Ben, I'm gonna do this on camera for a second. In the background,
to 10.
you want my arms to be the magnet spinning this way and the ball right where my head is. Just say yes or no if I'm getting that correctly. Richard Muller, a hollow sphere just like a UAP on Skinwalker Ranch in
That's
the Earth's magnetic field that is spinning and has the RF field.
Who said that?
That was Richard Muller.
Oh, Richard Muller. I like that. Muller.
He lives right here.
That you hit a nail on the head. That's exactly what I would love to do. Instead of using magnets or solid magnets or a magnetic ball, just have the actual a hollow ball, a magnetic hollow ball, or something along that side. Maybe even a hollow ring. It would be interesting to see. That's a great idea.
John Visker. Only more Teslas will increase the distance. Frequency of the rotating field may also influence the operational distance.
Right. So one of the ideas was to say, instead of just a neodymium magnet, what if it was a magnet sphere or anything like that, or even the square one in a Hausbach orientation? And then also you can add multiple ones. I'll have to post a link. There's some more of this stuff being done by another researcher as well.
Bannon says, you guys are awesome. Love what you're doing. Do you think the UAPs are man-made? Like, is this technology possible?
The spinning magnet technology. I mean, we are doing the Alzofon experiment right now. That's way better than spinning magnets. But I mean, it does make me wonder. You know, you've seen a lot of the times UFOs, or at least in the movies, they're depicted where you have a spinning one side from another. Maybe it has some kind of relation to that. Maybe the right materials and the right speeds, it would actually create a different levitating effect. A lot of folks are working on that. I know spinning Mercury, there's thoughts about that. Other vortexes, I don't know, Mark, you let me know. You know this better than I do.
Of what?
Where the UFOs rotate. It showed like the center piece standing and then everything else rotating.
Yeah,
Not sure yet.
not sure. I mean, Paul Potter has a book on it. A big yellow one in the break room.
Bill Schwant answers, yes, they are man-made, and yes, it's possible. Visker, thank you. I will look more into it.
It's on the rotating fields.
So yes.
Yeah, for 2 seconds, I'm just going to copy the name and paste it into the...
Paul Potter.
Yeah.
Like Harry Potter, but Paul. Mark, I
No, I feel like I'm. Let's not just keep the conversation going.
I just had it.
So what are you seeing so far? You're seeing an increase in the fall again?
Yeah, I mean, you can see what's happening. It's just the weight is probably somewhere.
There you go.
in the middle here. I think maybe in the next run we'll shut off the quadrupole and see how it just runs without it, without the propulsion.
I'm going to copy that link. I'm going to paste that into the YouTube comments.
Well, this is the kind of stuff we do every day. If you want to come and join Falcon Space, shoot us an email. mark@falconspace.org.
I joined.
Yes, Nedd Popovich came.
Thank you for having me. It's a pleasure.
Thank you for coming.
And thank you to the whole APEC community, actually. Thank you to the APEC community with Tim Ventura. Mark was also the founder. I've been there from the beginning, and I love doing that. So you guys check that out as well. You can see it right behind me. Right there.
APEC, the Alternative Propulsion Engineering Conference. That's where it's at. Marcus, you want to say goodbye?
See you guys later. It's been fun reading the comments.
Live long and prosper.
Remember, imagination is more important than knowledge, for knowledge is limited.
Yes.
Einstein said that, not me.
Okay, we're going to end this now. See you on Saturday. Yes. Lots of love, everyone. Love, love, love.
Comments are still coming in. We can keep this going all day.